So for the first part of our lesson today, we're going to be starting by just taking a look at a right triangle and how we name some of these parts. So if this does not seem super familiar and easy to you, I would suggest that the very first thing you do is take some time, write down these notes, so you'll be able to look back at them later. All right, now as you take a look at this picture here, the same one that you need to know and really have in your notes if need be, one little detail that's important to notice and makes all the difference in this one is the fact that there's this little arc drawn at this angle. Whenever we're naming sides of a triangle, we have to know which side we're actually going from, or I'm sorry, which angle we're going from. And so in this case, we're told that we're going from this particular angle. And that's how we can actually know some of these other pieces of information, like the opposite. Notice the opposite is the side not touching the angle. Hence, we have to know which angle it is that we're going from. When I talk about the angle, I'm talking about that one that we're going from. It is not a matter of the right angle, because all of this information presupposes that we are working with a right triangle. So we should already have the right angle in there no matter what. And so it's a matter of distinguishing between the other two. So opposite. It's the side not touching the angle. Literally, it is on the opposite side of the triangle. Nice, easy way to remember it. Adjacent. It's the side next to the given angle. And yet, you'll notice our angle is actually touching two different sides. How do I know which one's the adjacent? Well, the adjacent is the one that's not the hypotenuse. So as I do these, oftentimes the first thing I will do is actually try to figure out which side is the hypotenuse. The hypotenuse is always opposite the right angle. A hypotenuse is also the longest side in the triangle. It just has to be a right triangle, but as long as it is, the hypotenuse is the longest side. So those are a few little things you can do as you go and do these. So now start with hypotenuse, then figure out the opposite, and the adjacent then is the third side. It's the side that's touching the angle, but is not the hypotenuse, basically. Now, you're going to be asked a lot of questions early on just in terms of deciding what do we call each of these sides, opposite, adjacent, and hypotenuse. Those are going to lead us into sine, cosine, and tangent down the line. But we need to be really solid with those identifications in order to be able to do those later on. All right, so to practice this, I just want to take a look at how would we go about naming each of these sides. Now, in order to name each of the sides in this triangle, I have to know which angle I'm going from. And so it's often given in words above it. In this case, we're told specifically that it's from angle A. And so I'm going to go ahead and mark that on my picture just because it makes it a little bit easier to visualize what all is going on. In fact, when I'm doing these problems on paper or computer, I'll often just kind of put my finger on that angle as a way to keep track of what everything is relative to, because everything is relative to that particular angle. All right, so from there, we need to identify first up the opposite. Well, opposite is literally on the opposite side of the triangle. So you notice what that's pointing at. That's pointing at A. Now notice here, though, that is a lowercase a. That is an important distinction. Lowercase letters are always used to represent sides and side lengths. Capital letters are your angles, or your vertices, is another way to be fancy about saying it. All right, next up that we're asked about here is the adjacent. Well, there's two possibilities for that. It's either B or C. Which of those is the adjacent? Well, it's the one that's not the hypotenuse, and so that is C, because I can know the hypotenuse here is B. How do I know that the hypotenuse is B? Because if I take a look at where my right angle is, side B is opposite the right angle. Therefore, B is the hypotenuse. All right, now, each of those answers was relative to angle A. What if I change the angle? Same question, same triangle, but this time we're going from angle C. So if I'm going from angle C here instead of from angle A, which side is the opposite? Well, notice that is now the opposite of the particular angle that we're dealing with. And so the opposite is now c. Yes, lowercase c, because it's dealing with side c. And so by changing the angle, we also changed which side was opposite. And accordingly, it's also going to change which side was the adjacent. So the adjacent here ends up being side A. So what about hypotenuse? You notice the hypotenuse didn't change. Hypotenuse is still B. Because remember, hypotenuse is always whichever side is opposite the right angle. And I didn't move where the right angle was. I didn't move the labels either. So the hypotenuse is still going to be the same at B. One other thing that comes up along the way, though, with these is, well, what if we were going from angle B? What would we call those then? Because angle B here is my right angle. Well, you'll notice if I asked you in terms of from angle B, I can't identify the opposite or the adjacent. The only thing we could know is what the hypotenuse is, because the hypotenuse wouldn't change. The hypotenuse would still be little b. That's still whatever is opposite from the right angle. But we can only talk about opposite and adjacent if I know what angle of those two I'm going from. It's always the non-right angle that everything is relative to. All right. Now, one of the other things that's going to be coming up is we're going to be dealing with right triangles a lot, yes, but we're also going to be dealing a lot with circles in this section. So you'll notice some questions are coming up right now about where is this angle? What angle is this on the circle? And so where is 90 degrees in this picture? There's actually one particular location where 90 degrees is. And this is the sort of thing you're going to need to know really early on. Now, in order to identify where it is, it's probably good to have a little bit of detailed information. This is again going to be good stuff to put into your notes if you didn't already know that answer quickly off the top of your head. Notice here, 0 degrees is straight to the right. So that means that as I look at this picture that we've drawn, this would be where 0 degrees is. 90 degrees is straight up. So this is actually where our 90 degrees would be. And 360 degrees, that's the full circle. And so 360 is also equal to the same thing as 0 degrees. Because, of course, 360 degrees in a circle means you've gone all the way around and you got right back to where you started from. Now, notice that we always measure from 0 degrees, that is from the right horizontal. We always measure from 0 degrees and we always go counterclockwise. No matter how far around the circle we're going, we always go counterclockwise from 0. And so now if we go back and take a look at that problem that we saw before where we're asked to find the angle of 90 degrees. 90 degrees we know is going straight up. Depending on the context, sometimes you'll see a person describe it as that point right there on the circle where it's straight up. Or some people will describe it as this angle right here being 90 degrees. They both mean the same thing in this context about talking about the circle and where it lands on the circle. So then, where would 270 degrees be? So to find where 270 is, basically we just have to kind of keep going around the circle as far as we can to know where that is. Now, how much of the circle would that be? Well, there's different ways to know it and different things we can talk about, but one thing that you can do is to think about 270 out of the whole circle. If you did 270 divided by 360, it'd give you an answer of 0.75. Or perhaps something that's a little bit more useful to think about, 3/4. So in other words, 270 degrees is 3/4 of the way around the circle. So this is where 270 degrees is. Is it straight down? And when we talk about where that angle actually is, remember we're going around all the way. This particular instance is not talking about this angle down here. It's talking about the angle around the top and around the outside there. All right, so then where's 180 degrees? And again, there's a couple ways you can know what it is. You could go ahead and do 180 divided by 360 to kind of figure out what fraction of the circle it is. It ends up being about half of the circle. Well, 180 degrees, yes, that is in fact exactly half of the circle. So that's 180 degrees as we take a look at our picture. So we've gone exactly halfway around at 180. Now, those three numbers that we just talked through, 90, 180, and 270, get to know those. Get to know those really well, because those are kind of our little increments that we use in terms of looking at all the other angles, in terms of knowing where are those going to land. So like if I give you a question like this, find the angle of 135 degrees, where would that be located? Well, if you know where all of those other angles are that we were just talking about, the 90, the 180, and the 270, and even the 0 over here, we can know where 135 is partly just because we can know it's got to be somewhere between 90 and 180. So that already tells us which quadrant of the circle it's in. Quadrant, you'll notice, because the circle has been divided up into 4 different pieces. So we know it's somewhere here in the top left. Okay, the question is then where? And 135 happens to be halfway between the 90 and the 180. And so 135 degrees, it's actually right here. And so we're talking about this angle as you look at the picture. Now, I mentioned quadrant, right? Now, there are 4 different quadrants to this thing. Do you remember how the quadrants are named? Like, which one would we call quadrant 1? Well, what's the very first quadrant you go into as you're measuring an angle from 0? Well, remember 0 degrees is there. And you start going counterclockwise. So the very first quadrant that we go through is that one. And then what's the second quadrant that we go through? It's got to be this one. This is why they're named the way they are. So the first quadrant is the top right. The second quadrant is the top left. The third quadrant then is the bottom left. And the fourth quadrant is the bottom. Now that can be useful to also put into your notes as a reminder, because as we go through this unit, we will be talking about which quadrant angles are in. It's just part of how we talk about it. I don't want those things to lose you. So maybe make a quick sketch of this picture here so you can remember which one goes where. All right, so having done those, if you see a question that's phrased like this, remember earlier we figured out where 135 degrees was. We figured out that that was that angle right there. Which quadrant is that? Yeah, this one is the second quadrant. So like if you see this kind of a question, in which quadrant is 135 degrees? You would say the second quadrant. That would be the type of way you would answer that sort of question. All right, so again, finding out where the angle is. Where is 190 degrees in this picture? And again, in order to know this, knowing those 90-degree increments are important. The 0, the 90, the 180, and the 270. By knowing those, these problems get a lot easier, because 190, that's just 10 more than 180, right? So it's like saying go around to 180 degrees, then go 10 degrees more. Now, I'm not going to expect you to be absolutely perfect with that. It might be there, or it might be here, but we should be able to at least get pretty close with those. And so we could say that 190 degrees is right around that point. Now please visualize again, where would 57 degrees be? And be as precise as you can as you look at that point. And as I'm doing these problems, the first thing I notice is that 57 is between 0 and 90. So I already know that it's in the first quadrant. Now, if I know it's in the first quadrant, it's just a matter of how far through it is it. 57 degrees. Is that going to be more or less than halfway through the first quadrant? Well, halfway is about 45 degrees, because that's half of 90. So yeah, that's going to be more. And so we would then estimate that it's going to be maybe right around here. It's a little bit more than the 45 degrees. All right, and then this is the last one we're going to be doing together here. Where would the angle 312 be? Visualize that, please. And for this one, which quadrant would that be in?
Fourth.
Yep, that's the fourth quadrant. So we know it's going to be somewhere down here. Then it's a question of how does it compare to the 270 and the 360 degrees that it's between? Well, in this case, it's pretty close to half. Exactly halfway between 270 and 360 is 315. So you notice it's just barely less than half. And so we could estimate that it's going to be like right down there, or maybe a little bit closer to 270. You know, we're kind of roughing it out as we draw these out.